Welcome, ladies and gentlemen, to your MN22 notes, where we're going to prove triangles are congruent by side, side, side. This is section 4.3 in your textbook. This is going to be a shortcut to proving triangles are congruent. In the previous lesson, we had to show that all corresponding sides and angles were congruent in order to determine if a triangle was congruent. Well, this cuts that work in half by saying, you know what, if you can show that corresponding sides are congruent in triangles, then you can go immediately and say the triangles are congruent. To kind of say that in a little bit more simplified terms, let me just show you here in your note guide. If you have that length AB is congruent to RC, or RS, excuse me, and BC is congruent to ST, and AC is congruent to RT, you have all three corresponding sides congruent to the other triangle, which means then that the triangles themselves are congruent. And here's the congruent statement right here. So what we're going to demonstrate down here in the example 1 is by using the idea of side, 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 we're going to prove or determine that triangle JKL is congruent to triangle RST. There's all sorts of coordinate points there, so the first thing we're going to definitely have to do is graph these, and I'm going to keep moving this up here. So I'm going to create an axis on the note guide, and you can create your own axes. And I'm going to plot J, which is -3, 1, 2, 3, -2. I'm going to label that as J and also put -3, -2 there. K is 0, -2. L is -3, -8. And there's one of my triangles. And if you note, we've got horizontal and vertical legs, which means you've got a right triangle. And now that I've plotted these 3 points, now I'm going to plot the next 3 points for that other triangle. So 10, 0, 1, 2, 10, -3, 1, and 4, 0, 1, 2, 3, 4, not going anywhere on the y-axis. So here is again another right triangle. And we are going to again determine if those two are congruent. They don't look very congruent, but we're going to determine that in a moment. So the first thing we're going to do here is find the lengths of our sides. So for instance, I forgot to label this letter T here, which is 4, 0. So the lengths that we can determine quite quickly are these horizontal and vertical legs. So for instance, I'm going to have a leg from TR. I have 1, 2, 3, 4, 5, 6. So this length is 6. And I have a length of 3 right here. Over here, I have a length of 3 and a length of 1, 2, 3, 4, 5, 6. So while they don't look congruent, they're kind of looking that way. But let's kind of go through the steps here. We have JK segment is going to be congruent to RS segment. So that's one of your sides. And remember, in order to say these triangles are congruent, we need to show that all 3 sides are congruent or corresponding sides are congruent. So now we have JL, and that's congruent to TR. So there's another side. And lastly, we need to talk about that LK and the TS. If we can show that those are congruent, then we're good to go. And you know, at this point, typically if it wasn't a right triangle, you would use your distance formula to find the length from L to K. Same thing with t to s. You could use your distance formula to determine if those lengths are the same. But really, because these both are right triangles, the easier way to do it would be to definitely use the Pythagorean theorem to find that third side. So that's taking your legs and squaring each one, and that will give you your hypotenuse squared. So we have 9 plus 36 is equal to c squared. This is going to be 45 equals c squared. And when we take the square root of 45, that is going to be our length. So we have a length of 45 here. And over here, if we use the Pythagorean theorem, clearly we would get the same exact thing. Now keep in mind, again, these are right triangles, so it's a little bit easier to see that those both the hypotenuse would be the same. But you would definitely have to prove it. So LK and TS are congruent, which gives me my third congruent side. So down here, we can say that triangle, and I'm going to say JKL is congruent to triangle. And since I started at the right angle, I have to start at the right angle. So triangle R and ST. And the reason why we can say this is because we're by the side, side, side postulate. So because of the side, side, side rule, you can say these triangles are congruent. So that really is it when it comes to this section. And really, I can't stress how much easier it is to prove triangles are congruent by not showing all corresponding angles and sides are congruent, but in this case, to cut the work in half and just show that the sides are congruent, and then you can say the triangles are congruent. Thank you for tuning in.